Hi everyone, this lesson is for my Algebra 2 honors class, and we are reviewing quadratics and factoring the quadratic. So let's get started. We're going to start off with these questions and factoring by the greatest common factor. We're going to factor out something that's common between these two terms, and that would be a 9 and an a. So factoring that out, factor means divide. So basically we're dividing out 9a. So if it helps if you draw like a line underneath and say 9a underneath both of these, that's completely fine. But the answer when you factor that out, and you can't just divide it out. A lot of kids will just like, oh, I'm dividing it out, it's gone. But you have to show that you actually factored it out. Unless it's an equation, then they're actually gone. But this is just an expression, so you don't lose those terms. So you got 9a times the quantity a, and then minus 2, and then b squared. And then you're done. Box that up. So this one is factoring a trinomial. Now I know some people do that cross what was that called? Anyway, they do a different type of factoring, which is completely fine. I use just factoring this way, although I am going to show you a different way to do this. This is x times x makes x squared. To make 35, options are 1 times 35 and 3 times 5, which I'm going to use, or sorry, 7 times 5, because that one of those is going to multiply and add up to be 2. If there's one negative sign, you're going to have a plus and a minus. Because this is positive 2 and my values have to add up to be this middle term, my 5 is going to be negative and my 7 is going to be positive, and then you're done. Factoring by grouping groups the first two terms and the last two terms. So what you're doing is you're looking for a common factor, like your greatest common factor from both terms. So for the first two, I'm going to factor out an x squared, and then what you have left is 3x minus 4. And for the second part, I'm also going to factor out just a negative sign, and it looks like a 9. If I factor out a 9, what's left is I get 3x and then minus 4. The whole purpose for factoring by grouping is to try to group so that these two terms are exactly the same. Because now I'm going to factor those two terms out. So I'm going to take that 3x minus 4, and I'm going to factor it out of these two, and then I get what's left is going to be x squared. And then when I take out of these two terms, this 3x plus 4, I have left minus 9. Now, the last thing you have to do, because that's a difference of two squares, is actually keep factoring. And so that's going to be x plus 3 and x minus 3. For this problem here, I think I would factor out an a, let's make that bigger, a squared. And I would factor, looks like a 4 will go into everything. So I'm going to take out a 4 and then an a squared. What's left is going to be a 7a squared. And then it looks like a 4a. And then if I took out a 4 out of this a squared, I would have minus 20. I'm going to keep factoring. This is going to factor. Let's see. So we have 4a squared, and then this is going to factor like that. And let's see, probably one of them's a 7a, one's an a. For 20, one's going to be positive and one's going to be negative to make a negative 20. And so I'm going to go either 5 and 4 or 2 and 10. If I made this a 2 here, that would be 14. Probably a 2 here, 10. Let's see, check the insides. Negative 10a. And then positive 14, which makes 4, which is what we wanted. So that's our answer. So, like I said, these are just simplifying. You're factoring. You can box these up. You're not solving, so don't set anything equal to 0. Don't add in any zeros. You just kind of box those up, and then you're done. Okay, so the next question. Now, this is this method. I know some people use this. That's completely fine. The British method does this. This is what it says. In order to factor this way, you got 3x squared plus 10x plus 8. I mean, yes, you can factor like this. If that's your thing, then you can do that. The whole purpose of reviewing this factoring is just basically to try to help you factor better. And so the first step is basically to find two numbers that multiply to make a times c. So this is your a. So we've got the 3 and then we've got the 8. So what multiplies to make 24? but adds up to make 10. So what multiplies to be 24, but adds up to be 10? So that's going to be what multiplies to be 24, that but adds up to be 10. I'm going to say 6 and 4. So what they're doing with this British method is you're basically taking this middle term here, and then you're like splitting it up. So it looks like this. It looks like 3x squared plus 6x plus 6 times 4, 4x, and then plus 8. See how I've got 6 plus 4? I just rewrote 10 as 6 plus 4. And then what you're going to do here is you're going to now factor by grouping. So you're going to group the first two terms, and then you're going to group the last two terms. And realistically, it doesn't matter if you flip those around. You're going to get the same answer. We're going to factor out here a 3 and an x. And I have left an x plus 2. On the right side, I'm going to factor out a 4. And I have left x plus 2. And again, just like the previous page, we definitely, when we're factoring by grouping, are trying to get this value. It's got to be the same value because we are going to factor that out. So now I've got x plus 2 times what's left, which is 3x plus 4. And so realistically, if I had done this like up here, instead of done this by this method, then I would have said, okay, 3x times x. Both of these are plus, so these are both plus. What multiplies to be 8? So I've got 1 times 8 or 2 times 4. Those are my choices. So you just plug those values in, like 2 and 4, until you get that. 2x and 12, that's 14. That wasn't the answer. So then you would flip those around, and you would get 4 here and 2 here. 4x and 6x is 10x. So then we got the answer. So this is just another way of doing that. You might like it better. Let's do it again. Again, you've got to find two numbers that multiply to be a and c. So a is 6. So 6 and c is times negative 4. So that's negative 24. But they have to add up to be negative 5. So for me, I'm thinking negative 8 times 3 multiplies to be negative 24, but adds up to be negative 5. So that's your thought process, right? So you set that up and you go, okay, so now I've got 6x squared minus 8x plus 3x minus 4. So again, basically you're taking this negative 5 here and you're replacing it with this. Okay, so it's just another way of doing this. You don't have to do it this way. Take out a 2 and an x. So I take out a 2x. I have left 3x. And then minus, I took out this 2, which is 4. And then now, I can't factor anything out of these last two terms. So that's just going to be plus 3x minus 4, which is great because that's now the same. So when I factor that out, I get 3x minus 4 times the quantity, 2x, and then plus whatever's in there in front, which is 1. And then that's my answer. Now again, just note, yeah, if I wanted to do this without, doing the British method, I mean, absolutely, I can just factor it like this, just guess and check. I would probably try 2x and 3x to get a negative sign. One's plus, one's minus, and you just have to plug in numbers. To multiply to be negative 4, it's either going to be 2 times 2 or 1 times 4, and you would just plug numbers in. So like 4 times 1, so that's what, 3x, and then negative 8. 3 minus 8 is negative 5, so that works. Check. Okay. For these problems here, these are solving. Okay. You are solving by factoring. Now, I will say that by far more people make mistakes on this section than anything else because yes, you're solving, but people forget that these are quadratics, and quadratics have two answers all the time. So that means that a lot of kids will do this. They'll take the square root of both sides and they'll go, well, x equals 11. But there's actually two values, okay? It's plus or minus. It's x equals plus or minus. Plus, okay. It's x equals plus equals, okay. Hello. Equals plus or minus 11. The reason is this, for this reason. Let me show you. I will show you. So move this over. It's quadratic. You want to set it equal to 0. X squared minus 121 equals 0. Factor This is a difference of two squares equals 0. You've got x, you've got x. One's plus 11, one's minus 11. You split it up. You set both sides equal to 0. You get x equals 11. You get x equals negative 11. Done. This one right here, again, yes, you can move this over. Add 18. 63 plus 18. What is that? 1, 8, 11, 6, 7, 81. So 81 equals x squared. But you just have to remember that it's quadratic. So you have two answers. So when you square root both sides, you're going to get x equals plus or minus 9. Okay? You have to. And again, the reason is that you've got x squared. Bring this, it's quadratic. When somebody says this is quadratic and you're trying to solve, you normally set, that's like the first thing you do is set the equation equal to 0, always. And if I had done that, right, from the beginning and not done it that way that I just did, I would get x squared minus 81. Let me move this up. I would get x squared minus 81 is equal to 0. And then I would go, well, that's x plus 9, and then x minus 9 equals 0. And I would split this up, and I would say, okay, set both sides equal to 0. For this one right here, we're going to factor, unless you prefer the British method, completely fine. This one's already set equal to 0. So we go x here, x here. They're both plus, so plus and plus. 9, probably 9 and 3. 9 plus 3 is 12. We're done. So we're going to go x plus 9 equals 0. So x equals negative 9. X plus 3 equals 0. X equals negative 3. The correct way to write your solution is x equals solution set negative 9, comma, and negative 3. For this one right here, we've got x 4, 5. I'm going to say 5. So x minus 8 times x plus 5 multiplies to be negative 40, adds up to be negative 3. Split them up. Set them both equal to 0. X plus 5 equals 0, so x equals negative 5. X minus 8 equals 0, so x equals 8. So my two solutions in my solution set are going to be negative 5 and 8. This is a factoring problem. We are going to factor, it's an x to the 4th power, which means that it'll be x squared times x squared, right? And in doing that, we're going to get, looks like it's going to be a minus and a minus. So minus 4 and minus 1, because that's 4, and it adds up to be negative 5. Just a note, this is not quadratic because it's to the 4th power. It's quartic, which means four solutions. So we're going to set both of these equal to 0. We get x squared minus 1 equals 0. This, when I factor that, right, I get x plus 1 and x minus 1, right? Or unless you move the 1 to the other side and you square root it, you still get two answers. X equals plus or minus 1. For this one, if I did that, I get x squared equals 4. X equals the square root of 4, which is plus or minus 2. So my solution set for this problem is going to be x equals solution set plus or minus 1 and plus or minus 2. Ooh. For this problem, where's my, look at, that's x to the 1. Well, if you guys remember, when you multiply variables, your variables are, you keep the base and add the exponent. So to get 1, I'm going to have to use a half. So that would be a half, which is the square root. So we've got minus 4, so I'm going to go with negative 4, and I'm going to go with the square root of x plus 1, right? And let's see here. Square root of x times square root of x is x. Then we've got 1 root x minus 4 root x is negative 3 root x. That works. So then we set these equal to 0. Square root of x is equal to negative 1. I'm going to square both sides, but this is a problem here, okay? Because you have to ask yourself, before I even like manipulate the problem at all, right? When is the square root of any value going to equal to negative 1? This is going to be definitely no real solution for this value, for this part of the problem. For this, you've got the square root of x is equal to 4. You're going to square both sides, and you're going to get x is equal to 16, and no real solution, okay? For this one, we've got, I think for this one, we should have just factored and left the 0 off and just pretended that we were just going to factor. So that's what I'm going to do and not solve and just factor. That way, that's just really showing the review of the factoring. So I think that's going to be better. For this one right here, this is going to factor to get a half. You're going to multiply a half times a half, right? Because you're going to go, a fourth times a fourth. So because x to the 1/4 times x to the 1/4 is 2/4, which is 1/2. So this would be x to the 1/4 minus 2, and this would be x to the 1/4 minus 1 equals 0. We split those up. We get x to the 1/4 equals 1. If I make this to the 4th power on both sides, I'm going to get x equals 1. And on the left, we get x to the 1/4 equals 2. I'm going to go to the 4th power on both of these, and I get x is equal to 16. So the solution for this one would be 1, and it would also be 16. For this one, find the x-intercepts. That's what we're looking for. We're going to set y equal to 0. We get 3x squared minus 75. We factor out the 3. We get x squared minus 25. And so we get 0 equals 3 times x plus 5 and x minus 5. So we split all these up and set them equal to 0. My two roots are going to be plus or minus 5, which means that I'll have a value here and a value here. And then way down here at negative 75, my graph will cross the y-axis, so I've got a y-intercept there. For this one, I actually need to factor, so that's going to be x plus 5, and then x plus 3. Those add up to be 8. Split them up. We go x plus 3 is equal to 0, so x equals negative 3. X plus 5 equals 0, so x equals negative 5. So my two intercepts are at negative 5 and negative 3 with a y-intercept at 15, which means that my graph is going to look something like that. For this one right here, we definitely want to find the solutions. So in finding the solutions for this problem, we have y equals 0. So we're going to set y equal to 0, but it's already set y equal to 0 because I don't see a y here. So to find the x-intercepts now, I have to solve. So options for this are, we've got 4x squared, subtract 21x minus 18 equals 0. Because honestly, the first thing you should do is set the equation equal to 0. Anytime you're trying to find the x-intercepts, set the equation equal to 0. Okay? And so in doing that, I'm going to use the quadratic formula. So we're going to go x equals the opposite of b, so 21 plus or minus the square root of b squared, so that'll be negative 21 squared, minus 4 times a, which is 4, times c, which is negative 18, all over 2a, so 2 times 4. So use your calculator, simplify that, 21 plus or minus this value inside here. So I'm going to pause this and work that out. So I added in the numbers. 21 squared is 441. 16 times 18 is 288. You have a negative times a negative. It's a positive. 441 plus 288 is 729. So 21 plus or minus the square root of 729 over 8. So that is going to be 27. So we've got 21 plus 27 over 8. Split that up. And 21 minus 27 over 8. That's what that plus and minus means. You got two equations because it's quadratic. You have two answers. So you're going to go 21 plus 27 is 48 divided by 8 is 6. So x is 6. 21 minus 27 is negative 6. And negative 6 over 8 is equal to negative 3 over 4. And so those are your x-intercepts. So you've got one at 6 and you've got one at negative 3/4, okay? Which just tells you that if your y-intercept is at negative 18 way down here, then your graph is going to look something, and it's going to come down like this. That's not the vertex. That's just the y-intercept. So it looks something like that. Using the quadratic formula, solve. So again, we're trying to find the x-intercepts, and this is not going to factor, so we're going to use the quadratic formula. So remember, A is equal to 1, B equals 4, and C equals 5. So we're going to go x equals the opposite of B plus or minus B squared, which is 16 minus 4 times A times C, all over 2A. And so 16 minus 20 is negative 4. So what we have is x equals negative 4 plus or minus the square root of negative 4 all over 2, which is going to be x equals negative 4 plus or minus square root of negative 4. Remember, we did this in class, is negative, square root of negative 1 times the square root of 4. Well, the square root of negative 1 is I. Square root of 4 is 2, so that's 2i. So plus or minus 2i over 2. And what you need to do is you need to split that 2 up. Goes for both the numerators. So that's going to be x equals basically negative 4 divided by 2 plus or minus 2i divided by 2. And so that'll be x is equal to, what is that? Negative 2 plus or minus I. And then you're done. Now, if you were taking a test where they ask you to actually graph this, you would have to graph this on a complex plane where you have imaginary axis here and a real axis here. And you would go over 2 on the real axis and up I on the imaginary axis, and then over 2 on the real axis and down I on the imaginary axis. And that would be, those would be the points for the two solutions. Solve by factoring. So for this one right here, this one is split up. So this one looks like actually they want us to solve this by grouping. So I would take out a 4 and an x, and so we have x minus 5. And then here I would factor out a 5, and I'd have x minus 5. And so I would have x minus 5 times the quantity 4x plus 5 equal to 0. I'd split this up, set both equal to 0. So x minus 5 equals 0, so x equals 5. So one of my x-intercepts is 5. 4x plus 5 equals 0, so 4x equals negative 5. X equals negative 5 over 4. So like graphing that, these were my x-intercepts, 3, 4, 5. There's 1. And then negative 1 and a fourth would be here. My y-intercept would be negative 25, way, way, way down there. So it'd go probably something like that. For this problem, solve by factoring. Let's factor. Okay, set equal to 0. One's going to be 2x, one's going to be x. They're both plus, so these are both plus. So options are 1 and 5 or 5 and 1. So 5 and 1. Check, 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 check. 1x and then 10x makes 11x. So I'm going to split these up. I'm going to set them both equal to 0. So x plus 5 equals 0. So x equals negative 5. 2x plus 1 equals 0. 2x equals negative 1. X equals negative 1/2. So my solutions for this, put them in solution sets like this. X equals negative 5 and negative 1/2. That's the correct way to write that. So negative 1/2 is here. We'll say that. And then negative 5 is here. My y-intercept is 5, so that's right around there. And my graph is going to look something like that. That's all, meaning, and that's my minimum. That value down there at the bottom is a minimum. This is also a minimum. It's a maximum when your graph is upside down like that. That's a maximum. Okay. For this problem, we're going to use the square root method. So for this, I'm going to move this 50 over to this side. And what is that? Negative 26. So I'd have 2x squared. If I subtracted 50 from both sides, I would have 26. So equals negative 26. Divide by 2, I get x squared is equal to negative 13. And when I square root both sides, and solving, I get plus or minus. So x equals plus or minus this. And remember, that's going to be the square root of negative 1 times the square root of 13, which is plus or minus So actually, you put the I in a root. You always put the I after. So realistically, the correct way of writing this one would be the square root of 13. It's a root like that. I. And I would be like not under the root, but outside. I mean, it's not wrong to do this. I mean, totally fine if you prefer to do that, but they're the same thing. For this problem, I'm going to move this 3 over. So add 3 to both sides. I'm going to get 2 times x minus 5 quantity squared is equal to 18. I'm going to divide by 2. And so I'm going to have x minus 5 quantity squared equals 9. I'm going to square root both sides. And I'm going to get x minus 5 equals plus or minus 3. So I get x equals 5 plus or minus 3. So my roots are going to be 5 plus 3, which is 8, and then 5 minus 3, which is 2. So those are my roots. For this one right here, we're going to square root both sides, and in doing that, we're going to get x equals plus or minus the square root of 21. Now, keep in mind, it is completely fine to have a root as your answer. Like if I was graphing this one, I would have my x-intercept is at 2 and at 8, right? So this equation has a positive x squared, so it'll look up like that. This one right here, though, you got to ask yourself, what is the square root of 21? So obviously it's less than 5, more than 4. So that means that my roots are going to be 1, 2, 3, 4, 5. So here at the square root of 21, and 1, 2, 3, 4, more than 4, less than 5 here at negative root 21. So, and my y, so moving this over to the left, right, x squared minus 21 equals 0. Negative 21 is my y-intercept, which basically means that my y-intercept was way down here at 21, which is fine. And this is my graph. Looks something like that. For this problem, solve by factoring or by the quadratic formula. You know, again, you're just solving, so you're setting it equal to 0 first. I would go 9x squared plus 66x plus 21 equals 0. I would use the quadratic formula, x equals the opposite of b, plus or minus square root of b squared, so 66 squared minus 4 times a times c, which is 21, all over 2a, so that's 2 times 9. And then just use your computer, use your calculator to fix that, work that out. For this problem right here, you would go 3x squared minus 8x plus 4 equals 0. Now, you might be able to factor this one. Let's just look at the discriminant and see what actual kind of roots I'm going to get. B squared, which is 64, minus 4 times a times c. So that's 16 times 3 is 48. 64 minus 48 is positive, so I am going to get 2 real roots. I'm not sure this is going to factor, but I definitely am going to try. Set it equal to 0. We've got 2 negatives to make a positive 4, so one of these is 3x and one is not. To multiply to get 4, and it's 2 and 2, or I'm going to try 2 and 2. 3 times 2 is negative 6 and negative 8. I'm sorry, negative 6 and negative 2 is negative 8, so that definitely works. X minus 2 equals 0, so x equals 2. 3x minus 2 equals 0, so 3x equals 2. X equals 2 over 3. So my 2 x-intercepts for the problem on the right are 2/3 and also 2. And if I was going to graph that, you know, you just graph 1, 2, there's 1, and then here's 2/3. It looks like my y-intercept is 4, so right there, so the graph just looks something like that. They didn't ask for the vertex or anything like that. They want to know that you can factor or use the quadratic formula. So make sure that you can do that. Last one's just solve, and there's one little trick here. This one's easy, just x plus 1 equals 0, so x equals negative 1. This one is going to be x equals 5. You write your solutions like this, and so you have negative 1 and you have 5. For this problem, again, you split both of these equal to 0, and you're going to have, you know, depends if you're distributing. If you're distributing this, right, think about this. I'm going to divide everything by negative 1, and by doing that, that's going to lose that negative sign. It's going to go away. So you just set 2x plus 5 equal to 0, and 3x minus 5 is equal to 0. Because if I divide it by negative 1, the 0 divided by negative 1 is still 0, so that's gone. So we get 3x equals 5. We get x equals 5 thirds. 2x equals negative 5, and x equals negative 5 halves. For this one, though, by far the biggest issue that I've seen on certain tests, and that is because, yes, you want to set your quadratic equal to 0. This is not set equal to 0. So for this actual problem, you cannot solve this like this. You actually need to solve it. You have to multiply through and then set it equal to 0. This is a little bit tricky. So this is going to be 6x squared minus 21x plus 14x minus 49. See this 2? Move it over. Minus 2 and then equals 0. And then you'll have 6x squared, and then what is that? Negative 7x. And then negative 49 minus 2 is negative 51. And then you can use the quadratic formula, or you can factor. But by far, this is the biggest mistake that I've seen people make. Because again, see this 2? You have to move it over to the other side. You have to set the equation. So minus 49, that has to come over. Minus 2 equals 0. You have to set the equation equal to 0. So for homework tonight, you guys have a Desmos activity marble slide. So you can get started on that. And thanks for watching. I hope that helped you with your factoring. Okay? See you in class.